Hello again. I don't know what happened. I will try to use my new microphone. And here is our patient today. It is a Thomann branded The Box Active Subfoower amplifier. And there is something wrong with it. And now we have to figure out what is wrong with it. First of all, the fan is really sticky. You can almost, you can move the amplifier just trying to turn the fan, and it weighs maybe 5 kilos or something. So it is really stuck. But first we want to power it, and it has the, I don't remember the right term. It is a Spigen or Neutric connector. What is meant to put power in, but I don't have such a connector right now. But we can power it directly from here. So we don't need that connector there. And yeah, I know it is broken, but I don't know how. I have not tested it yet, so it will be kinda new trip to both of us. And hopefully we are able to at least figure out what is wrong. Yeah, let's just it felt kind of a little bit dangerous to do it like that. Yeah, I changed my mind. Wait a moment. Yeah, most of times if you have to think about it, that is it safe to do, then you probably just, it's better if you don't do that. And because there is a, of course, line voltage, and you can get killed, it is maybe better to power the circuit safer way, because we have a better way to do it and stay alive, perhaps little bit longer. I'm curious to see what is failed in the amp, but I'm as curious to try to stay alive. So I think we should do it, yeah, like that way. Yeah. Now we probably don't get killed by electric shock. Let's plug it in to see or not see what is happening. There is no power. Let's turn it on. Oh, we have a green LED coming. Yeah. And I heard the relay clicked. All right. Let's try to measure, are there any voltage in the fan, or is the fan like thermally controlled? But I think it is always on. Oh, but I was wrong. It is not. Yeah, you see, no voltage on the fan. All right. If I had to guess, that is probably that wire what is carrying the current or the power in the fan. But it is just a guess. There is 0. And I'm also trying autofocus thingy, but I don't know how the camera is handling it. But let's see. Now on. We have a power, we have a light. We have to feed something in to see if there is some kind of output of the amp. There is our input signal. We use only one channel. and we are going to hook that signal to my oscilloscope to see what is coming out. And for that I can use these leads to hook it to oscilloscope Let's hope that the leads are kind of sticking. To its place. Of course we could. Yeah, and we are doing. Let's build another cable like the power cord what comes in those connectors. I made that quickly. Just connectors and the wire end to safer connect inside the amplifier. And now when we are turning the amp, there is better spot to connect the oscilloscope probe wires. And yeah, let's see. I should have some function generator installed into my mobile phone, but it kinda don't matter because we have no sound. Of course, because we have no speaker, but at least I put something to go into YouTube. And let's turn the volume down and the amplifier on. And Yeah, there is nothing coming in out from the amplifier. Absolutely nothing. I could show you the oscilloscope screen, but I am not showing it right now because it is just a straight line and nothing happening there. So I don't kinda bother. There is nothing to see. But let's keep the audio playing. And I am going to probe directly from the connectors that the audio is even delivered to amplifier board. I think it is, if I have to guess, the audio is there. And I have no place to put the negative part. Let's try there. There is nothing. How about there? No. Interesting. Where is audio? Because I am not. Or will I? Let's play another song. I found it. It's there. It is the red wire is the audio signal wire. And my camera is running out of battery. So I think this repair will kinda end here. And I will continue from here some another day. And then we are focusing more in the main amplifier board. But at least that point we know the audio signal is getting there. And if I have to make a delicate guess, that board might have some kind of preamplifier, what we can check if the audio is coming in and out. And of course the main amp is heatsinked into the big aluminum chunk. So we need to kind of take all apart to see what is happening there. But we are ending that part to this and continue later on. Hello again. This is another day for the amplifier thingy, and now we are going to take the amplifier more apart and try to figure out that what is happening and why it is not working. Yeah, let's take it all apart, just because we can. And hopefully it starts to be clear what is wrong when we have been a little bit charging more. Yeah. Interesting looking board. But I don't think that our fault is here. But I don't know how to take the whole unit apart, but we will see. Let's first just unscrew what we can, and maybe we got luck and we see something visually blown. Okay, it was only external heatsink. Whoa, but it is now already coming apart like that. now we can get rid of that first section. Now we are starting to get somewhere. Yeah, let's screw more screws. There's really much put that effort to put the screws on the amplifier. And I turn it off now. That automatic camera thing, because it just did all the time tracking, and to me it looked really annoying. So I'm sorry, no automatic tracking anymore. Soon we will be inside of it. And the amplifier will expose its secrets to us. But first we have to get the amplifier MOSFETs moving, or at least I think that they might have them. Yeah, I think it is ready to get out. And it is, but it is somehow still stuck. Not anymore. Let's put that away. And quick peek underside. Yeah, flippity doodah. Now we have something. And just relying in visual tracing, our main output to subwoofer is here, and it is going through the relay to inductor and then these. So these are the main switching amplifier things, and I don't know what these are doing. Maybe the preamp, could it be? Oh no, there must be our switching. Yeah, switching mode power supply. Yeah, we have to be careful to not shock it. We have to measure the gaps, but first we have that input terminal and the filter board, and then the mains is coming here, and there is more filtering happening. Then we have our diode rectifier, so full bridge rectifier. It will take the mains input in here, and it is rectified to DC voltage here, and I'm holding my finger maybe 20 centimeters higher than the DC port, that I don't accidentally get shocked. It was yesterday when we last time looked for the item, but you never know. discharge resistors are bad, then sometimes there will be really big voltage charged on the capacitors, and it is really painful, and you could perhaps kill yourself. If you don't be careful. Yeah, the rectifier is good. And I think the power supply side of the unit is probably okay, because it is generating the voltage to here, what we need, and it is regulated to lower voltage because we have LED lights and everything in here. So first I would suspect something here, and we can also see something there. But of course I have to put it under the microscope to see better. Yeah, here we are, back again, and I'm not sure where we left last time, but I thought that I was trying to investigate more under the microscope to see what is happening here, and there is happening kinda nothing. And I have been measured the MOSFETs, they are good, and kinda started randomly to test capacitors and just carefully look around what the board likes and or what the board sees. And I noticed that one cap there that one cap is a little bit bulky if you compare it to this or this. So it is definitely a little bit popped out, so the cap is not feeling great, and it is rated to 15 volts. And what I found was that there is those two pins, what are the capacitor, and just nearby it is a regulator, that one. It is just commercial 12 volt regulator. So the something power is coming in on the left side and the right side is leaving that regulated 12 volts. And because the left pin is input pin for the regulator, then it basically means that the capacitor here is just for storing the voltage which is higher than that 12 volts. Where the voltage is coming to the cap is directly from here. These are the big capacitors here, what are the amplifier circuit capacitors, and we can measure soon, but the tiny PC board, what is here, that one, is faded in maybe 100 volts or something from this capacitor, and there is a switch mode power supply built in to the tiny PC board, and it is generating some voltage, I don't know what, where we are regulating the lower voltage, but it is not working, it is not regulating. So our fault is most likely here or the cap. It is possible the cap is sorted out, and that's why output of this switch mode power supply is really low. I think first we could try to remove that cap and then see what is coming out, or measure the cap. If the cap is shorted out, then we have a kind of reason to believe that the cap is only bad. But I have a hard time to try focus here, but we can see that there is some happening. Maybe the cap is leaked or something, so it might be good choice to take out the whole PC board and investigate it. And yeah, that is kind of plan. Maybe first steps for the repairing of everything is usually measuring the points what you know what there should be. Example, the power rails. If you have a 5 volt power rail or 12 volt power rail, then you kinda can accept that the output of some regulator is matched for that rail, and if you are missing some power rail, then of course you are going to end that kind of situation that you have a unit what is not working. But the power rails is really easy step to do first when starting the troubleshooting of some electronic thingy. And the regulators are kinda commonplace to fail in the electronics, because they can fail just because they can, or sometimes some kind of overloading situation. Example, a broken capacitor can cause the overcurrent situation, what is breaking the regulator. Oh, I have so much stuff right now in my desk. I have hard time to try to get about all what I need to the table. Maybe we should put some flux just to make solder flow a little bit better. Now we are talking. Now it should come. But of course it is giving me a headache because I am trying to show you something. It is so horrible long legs that it is really... Now it is going. No. Ah. Got it. Got it. Got it. So there is our tiny switch mode power supply. And yeah, I can already tell that it has been really hot because the PC board is turned to black. And let's see what this capacitor going to tell. Meter is in capacitor mode and capacitor is interestingly reading kinda okay, but it is bulky. It is bulky and I think it should have 400 micros. We have only 60, so I think we have to try to take that out too. There is that cap. Here. Here is our cap, and now you can clearly see that bulkiness on top of it. It is kinda barrel, and 470 microns. And if I have to guess, we are not getting it. Yeah, it's gone. It is no good anymore. Hi again. It has been a really busy times, and I have been working all another stuff, and I didn't have time for this amplifier thing, but I'm not sure where we last time left, but I think I suspected that tiny board, what is kinda little bit burnt out, and the function of the board seems to be that it is taking high voltage DC input and it is delivering 24 volts output. So it is buck converter, and I have been trying to figure out what is wrong with the PC board, why it is not working, and I even draw a schematic. So I took all the components off and measured and watched where the vias are going and marked all the components, and I found that I didn't have that connection there. So power supply for the buck converter driver chip, and after that I found that underneath the electrolytic cap is bad kind of loose, and not sure can I show you, but there is that hole what is taking, should be taking that via through the PC port to here, which is basically same point between the diodes what is here in the schematic. So the goal is now just repopulate the PC port and change few components what are kind of bad, and if I have enough lucky it will be working again. At least that is my plan. And every component is now taken off the PC port, and I have been measuring them that everything is good. So now they just have to go back in the right places. These kind of small parts, but if you are interested, it is wrong way. Wiper 22. But now I lost it, the notch. I have to check the chip right orientation. Or I can try to measure it, because it should have another and all drains. Yeah, these are all together, so it is this row, and Yeah. It is that way, where how the chip goes. Just figuring it out depending on the schematics. So these 4 legs are connected together. They are drain, what I measured, and these 2 are source, and meter went peep there, but nowhere else here. So now let's try to not turn it around. Here, this input, equal there. Counter, am I going to get there? Yeah, there. Right. Yeah, it's there. Almost done. Now it is missing capacitor that used to be here, but that cap is bad, it's broken. So I have to try put this bigger can to there. Or not. I found a little bit smaller, but it is still a little bit bigger than that original one. But this is way too big, and that is broken. And that is from donor port. It should be okay. It is okay. But I have to check. Because this cap is 33, yeah, and 10F. That 10F is, I think, the voltage rating. and it means something. Yeah. Oh no. What it means. I don't know what voltage that is. I have to grab some another. Yeah, I don't have the right one right now. But I think it is okay. Just whack the normal electrolytic there. Yeah. Now I am not 100% sure where that tiny capacitor is from, because there is another one also. But let's not worry about it too much, because it is only capacitor. If it is not right, it will just blow or something. So nothing kinda crazy is not going to happen. Yeah, it is pretty. It is almost like the original one. It is just a little bit better than the original. Oh, pretty. Really pretty. Look. How cool is that? It's good. Now I'm trying to twist it a little bit. And now I'll try to bend the leg through here. That I might be able to solder it that way, that through hole pipe is going to get soldered too. really difficult to try to show you what I am trying, but I'll try to show you. Because if I could get it to the through hole pipe thing, then I don't have to make any jumper cables in the board. So it should be looking more original. I almost got it. It is really tiny stuffs to try solder without microscope. Of course I have a microscope, but if I use it, then I can't show you nothing. So if I am trying to show you something what I am doing, I have to do it without microscope. Yeah, it should work. I have to measure it. Because the switching device VDD, so positive supply, should be connected to here, and it is good. That part never been populated, and only part what is now missing is Zener diode here, and it is that one there. But that is actually one part what I have been not tested. There is a Zener. I'm not sure is it good or bad. Okay, it's bad. It's bad because meter in diode mode and the zener is now oriented same way as it is on the drawing. So positive did here and negative here, it should show the voltage. What should be something really low, 0.5 or something, but it is kind of shortcut. And if I am trying to reverse, it should wait for the zener threshold and then start to conduct, but it is conducting all the time. And I think if we try to measure it, the ohm readings, we see the dead short. Yeah, it's broken. And I don't have it. Ha! I managed to find one. What is close enough? Maybe what there have been previously. But now it is ready for the test run. To see will it explode or give some DC voltage output. And little bit cleaning up. Before the installing, but let's try to create some kind of test circuit here. This little bit experimental because I don't have the high DC voltage source, so I am trying to use that one. It should give some DC output. And it is only a box where is diode rectifier inside of it. And if I hook it in my power supply here, it should give us some kind of DC voltage output. Yeah, and it is DC voltage here. It can go reasonable high. part is kind of working. I'm sorry for the glare. And now I just have to feed the power somehow. To our circuits. I think I can do it with this. And the DC input is going to the drain of the chip. So it is these two. So brown one is the red lead, and the red is going to be there. Like that. Jesus, I have too much stuff now on the workbench at the same time. It is not good. And the minus is going to orange lead there. Minus is going to there. And at this point I think I should have another voltmeter that we can monitor both parts of the circuit, input and output, in same time. One wire somewhere there. And the voltage output is the yellow one. Yellow. And they are sharing the same minus terminal, so I can can put minus example there. Yeah. If it works, I need few leads more. I forget that my another meter is not connected because the leads are here. It needs to be connected there to monitor the input voltage of the system and the ground there. Now I should have everything hooked up. Yeah, let's see what happens. The input voltage and the yellow one is output voltage of the system. They are both auto ranging but showing the DC volts, so let's see. Okay, the power cord is in and nothing exploded yet. Maybe I should wear the safety goggles. Now I am slowly cranking the voltage up to see what voltage is that switching thingy regulating out. Oh, but I forgot there is no output capacitor at all in the output side of the circuit. There should be a capacitor. Let's fix that. I think it can't be working correctly if there is no capacitor. Let's see, the capacitor should be sitting there. Now, let's try again. Yeah, we are inputting 100 volts and we are giving out 27 volts. And if I crank the voltage up, it seems to be working. 300 volts input voltage DC and output voltage is 27 volts. So yes, that part is now fixed and rebuilded. I think at this point it's really good to stop and continue to repair when installing that port back to amplifier. Thank you for watching and have a nice day. Yeah, here again, here is the main board from the amplifier, and that tiny PC board thing, that one is going to there, but before that there is one electrolytic cap what is needed to replace because the old one is broken. And yeah, then we can start to test the amplifier if it works. Or even will it turn on, because last time was situation that amplifier didn't even turn on. Aha. Now it should go. Yeah, it's there, and this tiny thingy needs to go there. All right. What will it do now? Before it was completely dead. But could it be this time doing something? Alright. And we don't have the power switch right now. We only have the power cord, but we might be interested to see the amperes, what the circuit is taking when I am trying to start it on. Because if it is showing some crazy high amperes before it even gets started, then we know that something is wrong. Yeah, let's try it. Alright, now I'm starting to crank the voltage up. Yeah, we have fun spin. We have small amount current. So at this point we are looking kinda good. Now we have to adapt our test bench more to get our oscilloscope hooked to system and some audio input. Yeah, it's look kinda alright. There's 32 Hz and I can make it go smaller or bigger depending what kind of signal I'm feeding in. So let's just put back all the pieces together and then we can start doing some kind of sound check. Yeah. I assume it is okay. Finished repair. I think when I get this video clip edited, it will be kind of frustrating long, but I am betting that there is someone in the world who are going to watch the whole video, even it is long, so I am not doing any short cutting for the edit. And yeah, I will test the unit, and if it is okay, then it will be the last video from this device. But if the test run somehow fails, then I have to start this repair again. But even how, it is now done, ready for the test run, and thank you for watching and have a nice day.